This lesson is part 2 of 2.3, starting with example 7. It asks me to find all the real zeros of this big long polynomial function. We're going to go to our calculator, and I have already typed it in. I just typed it straight in there, and I graphed it, and this is what I got. Now, this is one that your calculator lies to you. If this is all you see, then you're not seeing the whole graph, because the highest degree, oh, what have I done? I typed in 0.4. Tab. Let me fix that really fast. Why I typed in 0.4, I don't know. Okay. Now I have more of it. Oh, look, that's the whole graph. Your calculator did not lie. But you may need to zoom out a little bit. Let's change our window. It looks like I can't see the bottom of it. So let's maybe go, I don't know, negative 40. There. Now it looks like I can see my entire graph. It asked me just to find the zeros. So it looks like I have, well, I could see it a little bit better before. Menu, analyze graph, 0. So I have 1. Menu, analyze graph, 0. 2. Analyze graph, 0. 3. And 4. And I need to hit my plus signs on all of these. Plus, 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 plus. Okay, so there are my 4 zeros. Paste. So my zeros are x equals negative 3 point, let's see, 0.997 would round, the 7 would round the 9 up, and the 9 would round the 9 up, so it'd be 3.100. Yes, that is right. 0.5, 1.133, and 1.367. I knew that I had 4 zeros because it is an x to the 4th. And let's double check to make sure I typed that in correctly. Yeah, the rest of it was right. If it had been an x to the 3rd, I could not have had more than 3 zeros. X squared cannot have more than 2 zeros. Find a cubic function with the given zeros. Support your answer. I want you to think back for a minute. Just pretend. Pretend I had x plus 2, x minus 3 equal to 0. What do? You set your little parts of your problem equal to 0, and you get x equals negative 2 and x equals 3. Well, in A, I'm essentially going backwards. I'm giving you 2, 5, and negative 1, and you go backwards, and you say that what went with 2? Well, x minus 2, because if you set that equal to 0, you'd get 2. X minus 5, and x plus 1. And then you FOIL it out. So I picked 2 to FOIL. Be x squared plus 1x minus 5x, so minus 4x minus 5, and then x minus 2, and then I distribute through. X times x squared is x cubed minus 4x squared minus 5x minus 2x squared plus 8x plus 10. That's x cubed minus 6x squared plus 3x plus 10. So that one's done. And it says find a cubic function, so f of x equals. The next one, I would have 3 would become x minus 3, x plus 7, and x minus 6. I'm just going to fold the second two first. So x squared minus 6x plus 7x minus 42. So that's x squared plus 1x minus 42. Bring down my x minus 3, and now I'm going to fold it through. That's x cubed plus 1x squared minus 42x minus 3x squared minus 3x plus, I don't know. 126? 3 times, should be right, maybe. So x cubed minus 2x squared minus 45x plus 126, and that's f of x equals. Support your answer. If we graph that, let's see. No, I don't want to save anything. If I graph it, I graph x cubed minus 6x squared, x cubed minus 6x squared, oops, plus 3x plus 10, plus 3x plus 10. And if you look at your zeros, my zero is negative 1, 2, and 3, 4, 5. 5. Is that what I started with? Negative 1, 2, and 5, then yes. And you do the same thing with B. Okay. Dixie Packaging Company has contracted to make boxes with a volume of approximately 484 inches cubed. So, volume is 484 cubic inches. Squares are to be cut from the corners. Does this look familiar? Of a 20 by 25 inch piece of cardboard, and the flaps are folded up to make an open box. What size squares should be cut from the cardboard? Remember that these are my x's, and my length is going to be 25 minus 2x, because it's this distance. 25 minus 2x. My width is going to be 20 minus 2x, and my height is x. You should remember this from chapter 1. So why it says length equals, I don't know. It should say volume equals. And I want to know when my volume is 484. So I want to know when 484 equals 25 minus 2x. No need to fold it out. This is a calculator question. So we're going to go to our calculator. Let's see. New, nope, I don't want to save, nothing, graph. Let's see, what was it, 25 minus 2x times, whoops, not minus, times, I need to look at my problem, hold on, let me get my piece of paper, so I can know I'm typing the right thing in. 20 minus, really, I put plus, times 20 minus 2x times, what, why, times x, grief, struggling. Okay, and I also need 484, because I want to know where it equals that. I need to change my window. What makes sense? What's my domain of my problem? Well, can I cut an x out more than half of this side? Well, no. So it has to be between 0 and 12.5. So 0, 12.5. And I've got to get at least to 484, so how about 500? Just so that I can see it a little bit better. Let's go 5,000. Okay, that's a little too high. It's excessive. About 1,000. Okay, there we go. And now we can see it. And oh look, I have two answers. I have one here and one here. So menu, analyze graph, intersection. Menu, analyze graph, intersection. Okay. Plus. Pull them down here where I can see them. Capture page. That's huge. What size squares should be cut from the cardboard? Well, it looks like I could have squares 1 by 2, 2, 2, or by 1 by 2, 2, 2, and that's inches, or I could have 6.872. Now, why do I have two different answers? Well, I could have a tall, skinny box, or I could have a short, fat box. Like, I could have, God, what's the odds that I can draw this? I could have something like that, or I could have something like this. Wow, it's horrible, horrible drawing. And it'd be the same volume. Okay, that's it for this video.